Hi everyone, a quick review of Pascal's triangle and function notation. So Pascal's triangle is quite a simple idea and it can be used for finding the coefficients of polynomials. So Pascal's triangle, we start with 1. On the next line we have 1, 1. Then we have 1 on the outside, the sum of the two numbers above it in the middle, and 1 on the end again. For the next one we have 1, the sum of the two numbers above it, which in this case is 3, sum of the two numbers above it, which is 3, and 1 on the end again, and then so on and so forth for each line of Pascal's triangle. One thing to note is that this diagonal tells us the degree of the polynomial that we're constructing. So if we're looking for the expansion of x plus y to the power of 6, the row with 6 in it will give us all the coefficients. So we can see here 1, 6, 15, 20, 15, 6 and 1, which is a hell of a lot quicker than multiplying out 6 brackets of x plus y. But to use this property you need to be able to construct Pascal's triangle fairly quickly and understand which row that you need. And that's why I draw your attention to this diagonal, or in fact this diagonal, which is exactly the same. Okay, function notation. So instead of saying y equals 3x take 1, we could say f of x equals 3x take 1. It's an alternate notation. We use it for lots of stuff. Now, when we're using it, instead of saying given x equals 2 for y equals 3x take 1, substitute x equals 2 to find y equals 5. We could define f of x as equal to 3x plus 1, and if we say f of 2, that means put 2 wherever x is. So over here we've got 3x, so now we're going to do 3 times 2. Subtract the 1, which will give us 5 as per our first expression. On our calculator we do that through the interactive menu. Interactive, define. For function f, where the variable is x, use 3x plus 1. That little line on the end there is obviously a cursor, which in the main menu will spit out define f of x equals 3x take 1, like here. If we want to find out f of 2, we just type, or where x equals 2, we just type f of 2, and that would give us 5. Now, if we used graph and table mode, it works similarly. In graph and table mode, we could put in y equals 3x take 1. In this case, we've said y1 because we can put in 50 or so different equations. Over here, it looks like it's moved over a bit, so I'm just going to move it back. We can see that y12, this y1 that we used in graph and table, we can use in main, and it spits out 5 for us. If we want individual values of a graph that we're looking at, a quick way can be to flick back to main mode and check them all out rather than using trace, which can be a bit fiddly. Now, in both cases, y would be the dependent variable, x is the independent variable, x is traditionally the thing that we change, and then that subsequently changes y. If we're using functions in this define method, it's good to clear all the variables because it can mess things up later after you've finished with a defined variable. And that is pretty much all I wanted to cover in this one. So thank you everyone.